So I'm going to talk a little bit at the beginning of if someone wants to get controlled access data from Kids First, what is that process? And this is going to really continue from what Vivian described, where she gave a very, very clear introduction to the dbGaP process. So at a technical level, there's a certain amount of plumbing going on in the Kids First data resource, and Allison gave a good way to look at that. I just want to dive one level deeper into what happens. And the good news from a user's point of view, they just have to do two things. The first thing they have to do is go through the dbGaP process that Vivian described. The second thing they have to do is once they've done that, they do that once per year. When they are on the Kids First resource, if they get to a point where they want to work with controlled access genomic data, they just need to log on through their ERA comments. And this is for the dbGaP control data, not for some of the other kind of data that both Allison and Adam described. And then there's going to be the platform plumbing services that do authentication, authorization, and do the bookkeeping required and the security and compliance required to work with controlled access genomic data happen under the hood. And it's with a platform called Gen 3, which is one of the components of the Kids First data resource. And I think one of the nice things about the Kids First data resources is integrates multiple components from multiple of the providers out there, ranging from the wonderful portal and system that OICR has built to the Cavatica to some of the other components that are included in the Kids First resource. And so there's really three steps. First, one time, fill out the dbGaP process. Two, whenever you touch the data, log in with ERA Commons, and then everything else comes for free. So that's all that happens, and that's all you need to do to get access to Controlled First genomic data. And this is, as the Kids First resource sort of follows through the vision that Adam and Allison talked about and provide frictionless access to other applications and other types of systems. Again, this is all you need to do. You just have to authenticate with ERA Commons, and if you are allowed to see that data, you get access to it. So that's where we are today. I want to talk about where Kids First resource may go to in terms of being an example of what the Blue Ribbon panel called the data cancer ecosystem. So I'm going to give a very quick introduction to data cancer ecosystems and then talk about, at least from my personal perspective, some of the ways that the Kids First resource can play in there. You heard a much broader perspective from Adam and a sort of another perspective from Allison. So recommendation D, and the recommendations were given A, B, C kind of numbers because so that they weren't given Arabic number. They're given letter designations because they're all equally important. So D recommendations: build a national cancer data ecosystem, create a national ecosystem for sharing and analyzing cancer data so that research clinicians, and I can't read that, will be able to contribute data which will facilitate efficient data access. Patients, it must be patients. This diagram shows the four hubs: knowledge bases and data repositories, research tools and services, clinical decision support tools and services, and patient support tools and services. So we're going to focus on a few of these right now. And the question is, how do you go from this diagram in the Blue Ribbon panel report to something that's an actual system? So one step was taken by the NCI's interpretation of this through what's called the Cancer Research Data Commons. And this is a notional view where you have multiple commons, multiple sources of data, you have knowledge bases, repositories, applications, large-scale cloud resources, and all sorts of other things, including tool repositories. And there's a little glue in the middle called the Data Commons Framework that are some of the things that tie this together. And some of the implementation of the Data Commons Framework service is the Gen 3 platform that's the same one that's in the Kids First resource. And that sort of provides some of the glue. And I'm going to describe a little bit of how that glue works in a minute. And the important thing is no one knows how to build an ecosystem. And so the philosophy is as important as anything else. And I'm going to talk about the philosophy, because if we don't get the philosophy right, we won't get an ecosystem. We'll just get another data silo. And there's actually a separate ring in purgatory for people who build data silos instead of interoperating systems. And, you know, if you're a data architect, you want to stay out of that ring in purgatory, which is the ring for data silos. So one way to think of this is there's two types of data. The big data, the large files that Allison was talking about, these are the BAM files, the CRAM files, the images, the movies, and some of these other large files, which can be in one or more cloud resources. And oftentimes for projects, that data is 1,000 times bigger than all the rest of the data. All the rest of the data is the clinical data, the biospecimen data, the report data, that without which you can't really do the science and the discovery. And then there can be multiple commons, there'll be some framework services, and then there'll be multiple ways to get and make discoveries, from workspaces, from systems such as Kavatica, from perhaps in the future systems such as FireCloud, Jupyter Notebooks, ShinyR, all sorts of systems. And the question is, how do we glue this together, and how do we sort of work out how to do this? And the only way I claim to work this out is to get your hands dirty, build the systems, and see what works for researchers and what doesn't work, and to have an agile enough way that you can refactor if it doesn't work out. So I sort of like to think of the last 15, 20 years as sort of being this progression. We have large-scale cloud resources which allow us to do processing of genomic and other types of data at a scale we haven't been able to do before. We've been building data commons, such as the genomic data commons and such as the Kids First. And the sort of the next thing on the horizon is how we're going to interoperate these in a meaningful way that works for the researchers, works for the patients, to create an ecosystem. And that's what I want to focus on. Allison mentioned this. I have this view of what's called what you can call the narrow middle. This is the principle as an end-to-end design principle, which means if you're trying to build a large-scale system, you have to specify just enough, but if you specify too much, then you don't have the flexibility to innovate. So, for example, when we built the internet, we specified the TCP protocol, a few other protocols, but whenever we wanted to add a new application like streaming video, or when we wanted to add streaming music, or when we wanted to add real-time games, we didn't go back and rewire all the switches and routers and software stacks that created the internet. We innovated at the ends. We innovated at how to get data in and how to get interesting things out. And you can take a similar idea here. There's a certain tendency to say we know how to build these systems and to specify standards for building them. I'm taking the view that what are the smallest number of core services, such as authentication, authorization, ID service, metadata services, ability to access large data in clouds, ability to take project data like the clinical data and the biospecimen data and import it and export it, so that we can innovate on how to get data in, how to improve curation, how to improve interoperability, how to make discoveries. You know, a good test is if you specify ways to build these systems that are so rigid that you can't accept a new system like a Jupyter Notebook, then you fail. And so we are often very close to doing that. So this is what you can think of as a narrow middle architecture, and I want to illustrate this right now. So the Gen 3 system that Kids First uses is based on this narrow middle architecture I mentioned. It's part of the Data Commons framework. It's included in Gabriella Miller, and it's compatible with the GDC. And the question is, how can we take sort of framework services, however they're implemented, whoever implements them, however they become standardized, and build ecosystems. So we have, and this is what's in front of us over the next several months to the next year or two. So I want to focus on this, and I want to take some baby steps, propose some baby steps. So there are a few commons out there. There is essentially, except if the same person designs them, not a lot of interoperability. And so the question is, how can Kids First take a leadership role in providing interoperability for these kinds of commons? And so I want to walk through a simple use case. We're trying to work this use case with some top metadata. We have 9 projects with about 42,000 cases. We have 3 projects and about 5,800 kids from Kids First. And what is a way we can interoperate these that works out for Kids First, works out for top ed, works out for the researchers, and is based on a few principles. So one way to look at this is to have principles in which each of the commons is treated symmetrically, so that no one commons is more important to others. And so what this means is that, there are multiple commons. If the commons are going to be part of an ecosystem, they expose an API. Each commons has one or more data models. Each commons has access to data in the clouds. And then there has to be some way to bring data together from multiple commons. This could be done, you could assume a miracle. The miracle in the data curation business is when 2 groups use the same data model. That's one way to work, but that doesn't happen as often as you might expect. Another way to do it is 2 groups use a data model that are close enough that they can be manually or semi-automatically integrated with some of the services out there. Luckily, we have Melissa Handel, who's the world's expert on this kind of stuff. That's that little box on the right. So here to play, all you need is an API, a data model, and a willingness to try to figure out how to integrate them. And if the data models are disjoint, or when they overlap, they agree, we're fine. If they're disjoint, or when they overlap, there's not a lot of semantic distance, then they can be easily manually or semi-manually integrated. And if there's a big semantic difference, then we do that next year. And so this is the same diagram in which the framework services are at the bottom. This is not always the case, but in this case, you have common authentication, authorization, digital IDs, metadata, and ability to introspect each other's data models. And here we have sort of 2 dimensions. One dimension is, does the data go into a third system, or does it go into one of the other 2 systems? One dimension is, do you import the data, or does the data stay in each commons and you access it through the API? The other dimension is, what's the systems boundary, the compliance boundary, the security boundary, and the data use, data agreement, data certification boundary between the 2 systems. That gives you sort of 2 dimensions, or sort of a 2x2 square at the simplest of how you can interoperate. And so for definiteness, I'm just going to assume that we don't have a third system, but bring the data into one of the systems. It's symmetric. It could either be Kids First or Top Med or both. Once it's in there, it has to go into a compliant thing. That could be a compliant notebook, like a Jupyter notebook, a compliant system like Kavada, or a compatible compliant workspace that will be created. And we're done. And so what we hope to, what Kids First and our group is collaborating on is sort of a demonstration of this, where we'll do this over the narrow middle and hope to demonstrate this in 2 to 3 weeks. No pressure, but that's the goal we have to do it by.